criterion B. So some students perform an investigation into terminal velocity of a simple parachute. So what you need to do is you need to investigate the terminal velocity of a simple parachute. One of the students wants to investigate how the area of a parachute affects the terminal velocity. It is very clearly given here. The clue is already given to you, saying that how do you determine how the area of a parachute affects the terminal velocity. It means if you have a smaller surface area, will it increase the terminal velocity? Or if you have a larger surface area, what will happen to terminal velocity? It's an open-ended question. Okay, now you need to work on this. Suggest how one piece of equipment that the student will need to perform the experiment. What equipment do you need to perform the experiment? So therefore, now what you need over here? So when a parachute now is coming from a certain height, what you do is throw the parachute from here. Okay, and this is the ground. You fix the distance. Let us say, for example, I'm standing in the second floor of my building, and I throw the parachute from here. And as a result of it, as the parachute starts coming over here, I have someone standing over here, and he will be timing. Okay, at what time it reaches it. Okay, the moment it reaches, you calculate what is the time taken, and then you divide t divided by t, which will give you the velocity, and that's what you call the terminal velocity. Okay, assuming that the particle or the parachute travels with the same uniform velocity throughout its path. Okay, so towards it, what do you need here? This d is already calculated. Every time you are not going to measure the height. Okay, so you are going to measure what? What is the timing step? What do you need for timings? You need a timer. Stopwatch. Stopwatch, which is high resolution. High resolution stopwatch you need. Okay, preferably a digital timer. You can also use a digital timer to get this one. Okay, next step. The reason. What is the reason? Terminal velocity. Terminal velocity is calculated using dt is equal to d by t, since d is already known to us. D will be calculated using d. So d will be measured. D will be measured. Timer. Terminal velocity. Calculate. Okay. Right. Anything else? That's it. Then suggest and explain a hypothesis for this experiment. So what will happen? If you have a smaller surface area, this is the ground, it immediately falls. If I extend this to a larger one, then what can happen? The air resistance here would be colliding with this one, so it will be, the air molecules here will be colliding with it, and as a result of it, air resistance will be higher, the time taken would be lower, right? When time taken is be lower, then what will happen? The terminal velocity will increase. Let us write down in symbols. Time taken, timetable will increase. Timetable will increase. Terminal velocity will decrease. Okay, time taken is lower means the time taken, the value of the time taken is much higher. Okay, t value is higher, and the terminal velocity reduces. Why does it reduce? Because vt is equal to t by t. Okay, when denominator increases, automatically vt should decrease. Now we need to write it appropriately. Suggest and explain. So what is the suggestion? So you need to suggest a hypothesis and then you need to explain. So we can say if the area of parachute increases, which area? Once again, if the surface area of the parachute increases, then the time of fall also increases, thereby the terminal velocity will decrease, provided what? Provided air resistance is same, or maybe we will not even write this one. Just keep it over here until so much. Okay, because we are certain what can happen over here. Okay, and then what else do you need? What is in us? Explain a hypothesis. What is a hypothesis? A hypothesis is that larger surface area, more air particles will collide and hence creates larger upward force. Upward force, what is the right? It actually falls down and hence that upward force maybe yes. Then you define about thermal velocity. Velocity. What do you mean by thermal velocity? Thermal velocity is the speed at which upper air resistance balances the downward weight. Okay, and what else can we say? That's fine. So you can stop here. Sufficient for 3 marks. 3 marks. The first one goes for hypothesis. The second one goes for the reason scientifically, and the third one your definition, and at the same time revealing or going on and on with the actual experience. Okay. Next, state one variable that the student will need to control. Describe how this variable must be controlled, why it should be controlled. We can use mass of the parachute. Mass of the parachute should be the same. You can ask me if that is the case. If I have a smaller one, then definitely okay, this weight of this one will add to it, and if I have double the size of it, then more the weight of the parachute will be right. How can the mass of the parachute be higher? What you do is you change the material of the parachute in such a way that the mass remains the same. That is what you need to do. So therefore, mass of the parachute should remain the same. Okay, and let's say you can say mass of the, yeah, that's what you can say. Okay, then what else you need? How should the variable be controlled? Since you are talking about the mass over here, say you can use digital balance to measure mass of this variable. You can measure this. Okay, then why the variable has to be controlled? Why it should be controlled? So what will happen? Why do we get terminal velocity? Terminal velocity is when the weight of the parachute is equal to upward drag force. Okay. Larger the weight of the parachute, tend to accelerate never reach terminal. Hence, it is a crucial parameter to control. Okay. So you should mention all of the things. Then explain what results will the student will need to collect to ensure that they will have sufficient relevant data. So what results the students need to collect? How do you write? So you should be able to measure or to be able to get the independent variables. First one is independent. So towards it, you should do it for do the experiment or the range of values for the well, example. What is the example? You can say marriage areas can be systematically varied as 100, 200, 300, etc. till 700 centimeters. Can vary. Yeah. Then we have oh, this is only for 3 marks. We have written only for 1 mark. And then right experiment should be conducted thrice or for each independent feature. No, not for each one, for each observation. For each observation. This one. Area. So the second one, the average will reduce the inherent error experiment. So this is the second one that you can do it for repeated trials. And then what else can we have? Third, the outliers, the data should be removed before processing. It's the third one that you should do. Then, wow, that's it. We are done any entities. Okay, so see you guys again tomorrow. Once again with the new criteria, which is on criteria C. Thank you.